In this video, we'll be discussing the basics of installing, loading, and using packages in R. A package is a single distributable unit that encapsulates code, data, documentation, and tests. Packages allow individuals to extend the functionality of R and even share that functionality with the rest of the R community. The comprehensive R archive network is a network of servers that maintain the current code and documentation for R. As of May 2021, this contained more than 17,500 packages that each extended the base functionality of R in some way. Now, with so many to choose from, it can be a daunting task to try to identify the packages that are actually useful for your projects. But the community has several resources that can help you to get started. Obviously, you can visit the link here to the R archive network, but you may also want to check out the RStudio support page, as they have an article, which I've given you the link to here, entitled Quick List of Useful R Packages. And this page contains links and descriptions of the packages for several areas to help you get started. Now, in the rest of the video and in the notebook, we're only going to be discussing the installation, loading, and usage of packages. If you're actually interested in developing your own, then I would suggest you check out the online book R Packages, and the link for that is here at the bottom. This was written by Hadley Wickham and Jenny Bryan, and they covered this topic in great detail, so it's definitely worth your time to take a look. The R installation already includes a number of packages for you. If you want to find out what those are, you can either use the library function or the installed.packages function. These functions differ in that the library function is a bit more like the built-in help, and it provides a listing of the packages installed with a one-line description. And so if I run that here, you'll see that we get the help dialog to pop up. And of course, we can scroll down and see all the packages that were included in this R installation. The install.packages function, however, returns a matrix containing the same set of packages, but includes several additional columns of data that have items like the package version, its license type, and you can see many others here. And so these two functions give you a high-level view of what's available in your installation. But if you'd like to know more about a particular package, you can use the built-in help function with the package argument. So if we wanted to know what the base package entails, we could type help and then package followed by equals and the name of the package in quotes. And running this opens the help documentation for the base package. So all the help pages for packages should include very similar information as far as the package name, its version, the list of authors and maintainers, and so on. And of course, it should have an index of the functions or names that the package includes. So if I scroll through here, we'll see a listing of all the names that appear in this package. We can now drill down even further on some specific item in the package if we wanted. So if we wanted to know more about the trigonometric functions trig in the base package, then all we need to do is add the name trig to the help command, leaving the package argument in place. In this case, it's going to bring up the help page for the trigonomic functions that are provided as part of the base package. Now, if you only needed some specific information about a package, like its version or description, there are actually a few functions that can help you with this. For example, if I typed package and then hit the tab key, you'll see that I get a list of possible completions here. I can scroll through this list and select a function that I want. So for instance, I want to know the version of the base package. I can select the package version function and then pass base as the argument. And this will immediately give me back the version number for the base package. Likewise, I could use the package description function if I was only interested in getting the description portion of the base package help page. For packages that you would like to use but are not included in your installation of R, you can easily download and install them using the install.packages function. If you use this function in the console without arguments, it will open up a window displaying a list of available packages from which you can simply select and install those packages in which you're interested. Alternatively, you can specify the name of the package directly as an argument to the install.packages function to perform that package's installation. Currently, in Jupyter Notebook, this command does not open up the interactive window, and so we actually need to specify the name of the package that we want to install as an argument to the function itself. For instance, if I want to install Tidyverse, which is actually a very popular set of packages containing tools specifically designed for data science, and at the end of this notebook, there is a brief description of Tidyverse, including links to the Tidyverse homepage. But to install that, we would simply type install.packages and pass Tidyverse, and then just run the block. When we run this command, the first thing it's going to do is give us a list of dependencies, which are other packages that need to be installed in order for the package we're installing, Tidyverse in this case, to function properly. If there are any dependencies that have newer versions available as source code, then in the console, you'll be prompted to approve the installation of the newer version. In Jupyter Notebook, however, it just defaults to installing the latest version of each of these packages. In any case, once this process completes, the package itself and any dependencies are installed, but it's not yet available for use. Packages, with the exception of the base package, must be explicitly loaded before we can use any of their functionality or data. So, for example, the ggplot2 package, which is part of the Tidyverse that we just installed, has a dataset containing data on the fuel economy for 38 popular cars between 1999 and 2008. And this dataset is called MPG. If I type MPG and I run this block, I get an error. And the error states that MPG is not found. And this is because even though we've installed Tidyverse, which includes ggplot2, along with all of its datasets like MPG, we haven't actually loaded any of these packages yet. So to load a package, we're going to use the library function that we saw earlier, but this time we're going to pass to it the name of the package that we want to load as an argument. For example, we can load the entire Tidyverse package by typing library, and then pass Tidyverse, either with or without quotes, and run the block. And now, after all of this is loaded, we can now use the MPG dataset for whatever analysis we might want. So if I type MPG here again, we see that the dataset was indeed found and is available for our use. Now that we see that the library function can be used to load various packages, let's take a closer look back at the output of the library call where we actually loaded Tidyverse. In the first section, attaching packages, it tells us that several packages were actually loaded, not just a single package named Tidyverse. And this is because in this case, Tidyverse itself is made up of or includes all of these packages like ggplot2 and tibble and so forth. Now, if you don't intend to use all of these packages, you can instead only load the ones you really need. In this example, we were only interested in the MPG dataset. So instead of loading the entire Tidyverse, we could have simply loaded ggplot2 using the library function. In general, loading fewer packages results in fewer resources being used, and of course, less time spent by the code fetching all of these packages and all of their components. Another reason that you'll want to only load packages that you're actually going to use is that if you look here at the last section of the output on conflicts, we'll see that there are two functions that are in conflict between the dplyr package and the stats package. Now, a conflict occurs when a package is loaded that includes a name that has already been previously used or declared. So in this case, both dplyr and stats packages declare the functions lag and filter. And you may think at this point, so what? Well, why do I care where the filter function comes from, for instance? As long as it does the operation that I expect, what does it matter? And that's actually the issue. In this case, the filter function from the stats package applies a linear filter to a time series, and the filter function from the dplyr package is used to subset a data frame. Depending on which package was loaded last, our code using the filter function can have very different behavior, assuming that it works at all. And unfortunately, this sort of thing is going to happen, as there are literally thousands of packages that you could use, and the authors of these certainly can't guarantee that every name is unique across all packages. It's just not practical. So to combat this, R uses the concept of namespaces. And since we're not going to spend any real time on this here, I've given you a link to section 13 on packages, which is in the online manual and introduction to R. And in subsection 13.3, there's actually a lot more on namespaces. But briefly, namespaces allow us to partition the space of names. And this gives package developers the ability to use any name they wish within their package, as long as they define a namespace. But even with this, we see when we loaded Tidyverse, we had conflicts. So how did namespaces actually help us? Well, the double colon operator can be used to specify the package namespace from which a particular function or name comes. For example, to specify which filter function we want, we could say dplyr : filter, or maybe stats : filter, where the package namespace is given, dplyr or stats, followed by the double colon operator, and then the function that we want to use. For instance, if I wanted to use the dplyr one, I could type Again, dplyr, : filter. And now that we've qualified which function we're using, we can actually call it. So let's say we wanted to filter the MPG dataset that we loaded, but we were only interested in the rows of that dataset where Audi was listed as a manufacturer. We could pass the MPG dataset to the filter function. And then to perform the actual filtering, we can use an expression that returns true when the manufacturer column contains the string Audi. And there we have it. We specified which filter function we wanted to use, thus avoiding the conflict, and we were able to get back a filtered version of the MPG dataset. Now this seems great. Since we knew about this particular conflict in advance, we're able to write our code to avoid the conflict. Except that as packages receive updates, there may be name changes or additions to packages that result in new conflicts. And sometimes these may result in silent changes in the behavior of your code. So there's a package named conflicted, which you can install and load to make any conflicts in your code an error. So by default, R uses the last loaded name as the one it uses. And the conflicted package instead makes those conflicts an error so they can be more easily identified and prevent those types of silent changes. So hopefully this helps you to see that we can create a set of unique package names or namespace names and use those names to help differentiate between any common names used for functions or data or what have you. Now, just to be clear, a package name and a namespace are not the same thing. We can actually write packages that do not use namespaces. And so if you want to know more about that, then I'm going to strongly recommend you check out section 13 of An Introduction to R, as well as the online book R Packages. Again, the link to this you can find at the end of the first section in the notebook. Before wrapping up this video, there are a few additional comments I'd like to make. The first is that when loading packages, that is, when you call the library function, this is typically done first in any script or R session. So before you start any analysis or before you start any computation, just go ahead and load all of your packages that you're going to need in advance. And this actually serves two purposes. One is that it makes it easy to identify the needs or dependencies that your code has, since all of the library calls are first and right there at the top of the file. And two, it avoids any potential use of conflicting names. If you were to say spread out the loading of various packages in your code, it may be that a similar name has one meaning before a library call and another meaning afterwards. So if we were to use our filter function as an example, we could use the version of the filter function from the stats package for some time series analysis, and then load the dplyr package and use its filter function to grab data from a data frame. But without use of the double colon operator, any refactoring of that code that moves the library call to the top of the script will actually break this code. And so it is recommended that you do include all of your library calls first in your code, and then specify the package names for any conflicting functions using the double colon operator. The next thing I want to point out is that if at any point you need to know which packages are currently loaded, you can use the session info function, which will give you a listing of the loaded packages, along with information about your R installation, OS, and then several other items. And last, just to remind you, the RStudio support page does have an article entitled Quick List of Useful R Packages, and I've given you the link here. And this is definitely worth a look, as it includes links to and descriptions of packages that will help you with the loading, manipulating, visualizing, and even modeling data. There are links for high-performance packages, and even tools for working with the web. And also, as I mentioned earlier, the last section of this notebook includes a brief description of Tidyverse, along with links to the Tidyverse webpage, and a link to the R for Data Science book, which includes some good information on Tidyverse as well.